This video explains why I prefer to use SysML when I execute systems engineering on projects related to complex system development. Before we go on, I do want to say that my observations of other modeling languages are drawn from my personal interest in systems architecture, engineering, and modeling over the past decade. I've read pretty much every book available on the subject and have looked into these other languages to varying degrees to form my opinions. I'd like to stress these are not meant as ad hominem attacks, but they're my honest assessments of their relative value in accomplishing what I think is important, increasing the odds of program or project success. But I do remind you that if you are selecting a modeling language or tool to support a project, decide what's best for you. So with that, I'd like to share a few thoughts on SysML and its alternatives. So SysML is backed by Encozy and OMG, two of the major players in the systems engineering thought space. There's a growing tool ecosystem, both interoperable between each other as well as with adjacent tools. There are free and commercial off-the-shelf tools available from major vendors like IBM, NoMagic, PTC, and Sparks. I believe that SysML is general, broad, useful, and far easier to learn than its reputation suggests. I've had significant success educating ordinary, average engineers with mechanical or electrical backgrounds on how to read and interpret the diagrams. They're not terribly complicated, and we use a lot of derived work products like tables and matrices to support the effort, and they've come to really value the information that a competent modeler can provide them. So it's not nearly as scary as people let on. I also would argue that the effort involved in getting to a fully executable model often isn't required, and just some simulation-assisted modeling to ensure that your logic and activity diagrams and state machines is correct is often adequate. The level of effort to get to fully executable may not be worth it for some projects. I'd also would point out that, again, most of the complaints are tool and UI related rather than language related, and all these derived work products resolve most of them. And again, use what you need. One of the complaints is that SysML is too complicated and complex. Well, if you only need to do a use case diagram, just do that and don't get worried about drilling down into the deep bowels of modeling and activity diagrams or BDDs. Use what's appropriate. That is why I like it so much. If you're doing a lightweight system, a lightweight effort, you can do just a handful of diagrams and constructs. If you need more, you can go as deep as you need. I'm one of the arguably better practitioners using Magic Draw, and frankly, I only use a tiny fraction of what it can do. So, but the fact is, every time I've needed some weird niche property or the ability to do something, I've been able to figure out how to do it because of the power of the language and the tool. And keep in mind, SysML is always evolving and growing, and 2.0 is on the way. And so, as we find problems or things that need addressing, we're growing the language to be able to execute with some level of success and confidence. So with that, we'll move on to some of the competitors out there, and these are in alphabetical order. So first of all, there's AADL, which is the Architecture Analysis and Design Language. It's backed by SAE International, and there's primarily one book available out there. I have the title listed. And the intent was to grow an avionics description language and make it more generally useful. I've read the book, and again, there's a common problem that sometimes happens when societies extend into areas outside their core competency. This has happened before with SAE. They've done a lot of outstanding standards work, but there were times that they've encroached on ASM International, which does materials, and in this case it feels to me, and again, personal opinion only, like they're encroaching just a little bit on a domain that's more appropriately left to Encozy and more the larger systems engineering community. But with that being said, the intent of AADL is to let you develop an architecture model that can be used for documentation, analysis, or for code generation like UML. From my perspective, I don't think it's well suited for general systems engineering use. It's like writing code. It feels really heavy and clunky to me as a practitioner. I don't want to have to write code to describe my system. Now, that being said, and I'm not a software guy by background, so if you are a coder, it's possible this works great for you if you're working on software embedded systems. If so, I'm sure it's wonderful for you, but I don't think it has that much incremental benefit versus UML and the ability to code generate from UML. So if you are being asked to use this, I would explore it carefully and make sure that you understand the necessity. DoDAF is the Department of Defense Architecture Framework, and UPDM is a unified profile for DoDAF and MoDAF. It's often mandated by the government, and frankly, SysML can be used to satisfy many of the required views. They're becoming more and more integrated, at least as far as answering the questions, and so from my perspective, I'm happy to peacefully coexist with DoDAF. LML is the lifecycle modeling language. It's available at lifecyclemodeling.org, and it was put together by a steering committee of practitioners who believe that SysML is too complicated, and it's been released as an open source standard. So there's 6 goals were to be easy to understand, easy to extend, and the rest of the one that you see there. From my perspective, you can do pretty much all of that if you're a competent SysML modeler and know how to use stereotypes and use the language well. So, and there is pretty much single vendor support from InnoSlate and Spec Innovations. From the specifications section 2, there's a statement that current SE languages add complexity to already complex problems, making it harder to communicate the underlying issues and develop solutions. I couldn't disagree with this more. I believe that complex problems have a high inherent complexity that keeps them from being oversimplified, and so for that reason, I view LML as having extremely limited utility and addressing a non-problem. Again, I feel that a competent system modeler using SysML can very quickly educate the program members, bring them along for the ride, so to speak, as the model is started and matures, finding ways to add value every step of the way with derived work products like tables and matrices that give the relevant information to the stakeholders in a format comfortable to them. So, again, if you're using this or considering using it, just make sure you understand what it can and cannot do before you adopt it for a program. OPM, Object Process Methodology, was developed by Professor Dov Dory at MIT. It's now an ISO standard, and there was a recent book that he's written, Model-Based Systems Engineering with OPM and SysML. I know there are a number of companies out there that use OPM and are quite taken with it. From my perspective, I think it's very interesting, but I think it's inherently limited. There's just only so much you can do with it, and it's kind of a dead end as far as getting down into the real weeds of what it takes to architect a system. So I think it's more useful for the conceptual side, and Dr. Dory has worked on ways to map and transition between the models, but again, from my perspective, that adds lag and drag, and I think it just has very unclear incremental benefit between SysML. He's done several papers showing that SysML adds value to OPM. I've yet to see any work that has any indication that OPM adds any value to a SysML modeling effort. And just starting off with some good context diagrams and use case diagrams, I think would probably do just as much for you. So again, OPM, many people have adopted it, are quite taken with it. I'm not personally convinced that it adds a lot of utility for the way I attack problems. So with that, again, I want to stress that none of this should be construed as a personal attack on any of the individuals behind these other efforts. It's just my honest assessment of their relative utility, and I hope that it fosters some honest discussion so we can make all these tools and languages better and more useful for their stakeholders. So with that, thank you for watching, and I hope you have a great day.